All right, we'll go ahead and get started with the lesson for today. Quiet, please. Definition of a derivative. This is second section of the third chapter. We talked about the limit definition of the tangent line. We talked about the difference between the secant line, and we talked about the difference of the tangent line. We said as h approaches 0 of f of x plus h minus f of x all over h. We said that equaled the slope of the tangent line, which equals the instantaneous rate of change. Okay? Instantaneous rate of change. Okay? We said the average rate of change was just f of x plus h minus f of x all over h. We said that was just the slope of a line, slope of a secant line, and that was the average rate of change. Average rate of change. Okay? So we're going to take those from section 1 and apply it to this section right here. Right off the bat, we talk about what is the definition of a derivative. And you can see it's very, very similar. The derivative of a function of f is defined by f prime. Well, we just said this definition equaled the slope of the tangent line. So it's the same thing. The limit as h goes to 0 of f of x plus h minus f of x. The only thing is this new prime symbol. The prime symbol means derivative. A derivative is a change of the function. Okay, so that's what a derivative is. If you want to know the derivative of a function, this will leave variables in your answer. You'll have a variable left in your answer when you're done with this. If you want to use the alternate definition, the derivative at a point. We've already been doing this also. We did this in section 3.1. We didn't call it the derivative, we called it the slope of the tangent line at the point a f of a. This is an x coordinate, this is a y coordinate on f of x. Okay? So, same definitions we have had, just a different word. The derivative, slope of the tangent line, also means instantaneous rate of change. Instantaneous rate of change. Okay? Rate of change. So, whenever you see those words, that's the definition you're going to use. Whenever you see those words, you're going to use that definition. We're going to be using it quite a bit today. I'm sure you have those written down. I'm sure you have them remembered. Another definition to take a look at is, there we go. There we go. Tangent line. We just talked about that. The slope of the tangent line in the graph of y equals f of x is f prime of a. The book is just defining it for the rest of the book. This defines it for Calc 1, 2, and 3. Rate of change is the instantaneous rate of change of y with respect to x is a f prime of a. Don't forget, a is an x value. F of a is a y value. F prime of a is a rate. You remember a rate? Distance over time is an example of a rate. That's what f prime of a is. I don't care if you have to memorize it. You have to know that stuff. All right? Nothing down there. So we're all set. This better go a lot better than last time I was going. I'll tell you that right now. So, with all that said, here's the first part of the definition you're going to have. It says, use the definition 3.5 to find f prime of x. Okay? So this part isn't even involved yet. I'm just going to use part A, f prime of x. F prime of x equals the limit as h approaches 0 of x plus h cubed minus 4 times x plus h minus, remember I always use brackets for the original function, x cubed minus 4x all over h. Okay? This p right here is only used in part C and D. Right now we're doing part A. And I have to simplify that. So, f prime of x, remember it means derivative. A limit as h approaches 0, and you expand it out. X cubed plus 3x squared h plus 3xh squared plus h cubed minus 4x minus 4h minus x cubed plus 4x all over h. We talked about when you do that, first thing you do after you expand it is you subtract. After you subtract, what the heck? Minus 4x plus 4x. Oh, it should be 4h right here. Sorry. Okay, I got to fix that. No wonder it didn't work. Minus 4h minus x cubed all over h. There we go. Now, everything left should have an h in it. So the derivative equals the limit as h approaches 0. You factor an h out, 3x squared plus 3xh plus h squared minus 4 all over h. Cross that off. Any remaining h's, any of those terms turn to 0. So those go to 0, those go to 0, and you're left with the derivative as 3x squared minus 4. Those of you know the shortcut already knew the answer, but still, you had to show me the work. It said use the definition. So that's what we did. We used the definition, and we found it, 3.5. Moving on, part B says find the domain of the derivative. Well, part B, since the derivative is a polynomial, I see no reason why the domain should not be all real numbers. So the domain of this, I'll just write it as all real numbers from negative infinity to infinity using the parentheses. Okay? I don't like how that looks. Let me change it. Negative infinity to infinity. All right? That's part B. Part C, find the equation of the tangent line of the graph at P. Well, first thing you want to do is 2, 0 on the graph or off the graph? This question is very difficult if it's off the graph. How do you know? You put 2 in. 2 cubed. 2 cubed minus 4 times 2. F of 2 equals 0 on the graph. Very easy to do now. Because the equation of the tangent line is nothing more than y equals slope of the tangent line x plus b. F prime of 2 gives me the slope of the tangent line, which means the slope of the tangent line will be 3, 2 squared minus 4. 4 times 3 is 12, minus 4 is 8. The point I'm using is 2, 0. So that gives me x and y. So I got the point, I got the slope, I just have to solve for b. So I have in 0 equals 8 times 2 plus b. b equals, I won't bore you with the details, negative 16. So the answer to part C would be y equals 8x minus 16. Yes, of course, you'll have to do this not once, not twice, several times in this class to show that you know how it works. So that was pretty good, 8x minus 16. And finally, I don't remember, part D, find the points on the graph which the tangent line is horizontal. What does tangent line horizontal mean? Thank you. It means the slope of the tangent line equals 0. That's what's meant by tangent line horizontal. It means the slope of the tangent line is going to be 0. So, for part D, if the slope of the tangent line is supposed to equal 0, and the slope of the tangent line is the derivative, that means I could put in 3x squared minus 4, and I can set it equals 0 and solve for x. So, 3x squared equals 4. That means x squared equals 4 thirds. X equals plus or minus the square root of 4 divided by the square root of 3. Of course, you have to rationalize. So x equals plus or minus the square root. To rationalize, you multiply top and bottom by the square root of 3. The square root of 12 over 3. That is where the slope of the tangent line equals 0, because that means where the derivative equals 0. Plus or minus square. Hey, wait a minute. That's the same thing as x equals plus or minus 2 square root of 3 over 3. Sorry about that. Didn't simplify it all the way down. I'm sure somebody in the room caught that. I was busy looking out the window at somebody else. Okay? So that's not too bad. There's questions 1 and 3 for you. And those directions are pretty good because they take along, that's the basic idea of this whole section. Using definition and derivative, find the equation, and moving on. All right. Speaking of moving on, I'm ready to move on. Here's an FYI. If a function is differentiable, then it's continuous at A. That means it's smooth. The question is the converse of this true? Excuse me. If f is continuous, does that mean it's differentiable? And the answer is false. So the converse is not true. Only the fact that if f is differentiable, that makes the function continuous. There are some other properties there you might want to write down. I'll give you a minute to jot those down. We'll talk about them. The first one, the derivative of a linear function is just the slope of the line. The first one, the derivative of a linear function is just the slope of the line. So that's pretty easy. If it's a linear function, it's just going to be the slope. Notice one thing. The b turns to 0, as evident in this last one right here. The derivative of a constant is 0. Okay? The derivative of a constant is 0. So, why is that? Well, a constant means it's a flat line. If you draw a flat line, what's the slope of the tangent line going to be? 0. Here's the shortcut rule you've been waiting for. The shortcut rule. If f of x equals x to the n, excuse me, the derivative means you drop the exponent down, then you subtract 1. It's a two-step process. First step, you drop the exponent. Second step, you subtract 1 from it. When you do that, it gives you the derivative, or the slope of the tangent line. It does not give you the y value. It gives you the slope of the tangent line, which is the instantaneous rate of change. Here's another one we talked about. Cx to the n, Cn x to the n minus 1. That just means you have a coefficient. That's what the C stands for, coefficient. And we've done those numerous times. So the coefficient. Wait a minute. let's see, I before C, except after, I before E, except after C. Something like that. Coefficient. All right, good. So that's the coefficient. Moving right along. Use 3.1 to 3.15 to find f prime of x. This means the shortcuts. So find the domain of f. Check. We can do that. Find the equation of tangent line. Check. And find the points where the tangent line is horizontal. So basically, you're doing the same thing, except you're not doing the definition. You're doing the shortcuts. So on this one, f prime of x equals 1/3 times 12x to the 1/3 minus 1. That's using the shortcut. Well, 1/3 times 12 is going to be 4x to negative 2/3. You can leave it like that, or you can write it as 4 over x to the 2/3. You can leave it like that. They might want you to rationalize it in the back. So you have to multiply by x to the 1/3 and x to the 1/3. So your final answer would be 4 times the cube root of x all over x. So you can have any one of those answers be fine. Only thing is if it's a multiple choice test, we'll give you a problem. The domain. Well, if this is part A, it doesn't take a rocket scientist to figure out part B. The derivative has a denominator. Denominators are bad for continuity. If you have a derivative with a denominator, that means the function is not going to be continuous at where the denominator equals 0. So the domain of this function is going to be obviously from negative infinity to 0, union 0 to infinity. X can't equal 0. That's that. Part C, find the equation of the tangent line of the graph. Remember, with part C, the first question you need to ask yourself, is this graph on or is this off? Is this point? Is the point on or off f of x? So, which one is it? Oh, no, I'll put negative 27 in. The function value of negative 27 equals 12 times negative 27 to the 1/3. Remember me? I like to take the cube roots first. So the cube root of negative 27 is going to be negative 3. 12 times negative 3, negative 36. It's on the graph. Life is good. We're very, very happy. So for part C, y equals the slope of the tangent line times x plus b. The slope of the tangent line is equal to 4 times the cube root of x divided by x. And that equals my derivative. So if I put in the x value of negative 27, that means I take 4 times the cube root of negative 27 all over negative 27. A bit sticky, but not too bad. 4 times negative 3 over negative 27. Cross those off, you end up with 4/9. That equals the slope of the tangent line at negative 2. So y equals 4/9 x plus b. The point I'm using is negative 27, negative 36. So I put that into the equation. Negative 36 equals 4/9 times negative 27 plus b. That gives me the negative 3. Negative 36 equals negative 12 plus b. b equals negative 24, I think. Add 12, looks like it. So y equals 4/9 x minus 24. All right, that's pretty good. And finally, find the points on the graph which the tangent line is horizontal. Well, for part D, when would 4 times the cube root of x over x equal 0, because that's the derivative? I say in this case, there won't be any. The only thing to make the numerator equal 0 is when x equals 0, and that's not in the domain. So since x equals 0, not in the domain, f prime of x cannot equal 0 for any x. Okay? That's not too bad. Moving along pretty good. So the only difference between the first 4 questions and these 4, one using definition, the other one using shortcuts. Using the shortcuts we talked about, a lot of you might remember from last year. Slope of the tangent line, I think I also hit that pretty hard last year. So you should be in pretty good shape with all that stuff. All right? All right, moving on. Find the first 3 derivatives. Since it doesn't say using the definition, you can use a shortcut. The first derivative, you would take 7/3 times 3, x to the 7/3 minus 1. You need to multiply that out. F prime of x equals 7x to the 4/3. Second derivative. Well, yeah, that's the derivative of the first derivative. So you're going to take 4/3 times 7x, 4/3 minus 1. So that's going to equal 28/3 x to the 1/3. And the third derivative is a derivative of the second derivative. So I'm going to take 1/3 times 28/3 x to the 1/3 minus 1. So you end up with 28/9 x to negative 2/3. Hey, you can leave your answer like that. You don't have to rationalize it. That's fine. The main thing is that the second derivative is the derivative of the first one. Third derivative is the derivative of the second one. Pretty interesting. I like that. This is a vertical tangent line. What's the equation? I'm sorry, what's the slope of a vertical line? Yeah, it's undefined. So if you have something that has a vertical tangent line, this is the definition of it. The limit of the derivative, the absolute value as x approaches a equals infinity. We've had functions before where it equaled infinity. For instance, the limit as x approaches 0 of 1 over x squared, that equaled infinity. So, if that was a derivative of something, that would be a vertical tangent line at x equals 0. And here's some examples of what a vertical tangent line might look at graphically. This is the definition. Okay? A has to be in the domain. A must be in the domain. Domain. You can't pull an X out of thin air. Notice these are all continuous spots. The main thing is they have a sharp point. It's a sharp edge. It's almost like a spike. It's not smooth. If you see that erratical behavior on the graph, then you know it possibly has a vertical tangent line. You can apply the definition. So, with that said, there's a follow-up definition. If, for instance, you approach it from one side and the other and it's positive or negative infinity, then you can say, besides the vertical tangent line, it actually has a cusp. A cusp is a very sharp, jagged edge. Notice the tangent line on the left would be positive infinity. It's going up. And on the right side, it'd be negative infinity because it's going down. Therefore, there's a cusp at A. That's what it looks like. Okay? So we might try a few of these. Is f differentiable on the given interval? This means kind of take the derivative, f prime of x, and which would be think of this as x to the 1/3, by the way. Be 1/3 x to the negative 2/3, which would be f prime of x equals 1/3 times the cube root of x squared. Does 0 work in this equation? Nope. Is 0 in that domain? Yep. So it is not differentiable. In fact, it's not differentiable because it's not even continuous. It's not continuous. Wait a minute. It is continuous. Let me back the truck up here. A doesn't have to be, it has to be in the domain of f of x, not the derivative. It has to be in the domain of f of x. Whew, that was a close one. So, the limit as x approaches 0 of the derivative, which is the limit as x approaches 0 of 1/3 times the cube root of x squared equals 1/0. The question is, it's going to be a vertical tangent line because it looks like, a vertical tangent, vertical asymptote on a regular function. Well, the question is, will it ever be negative? Will you ever get a negative value out for this? And the answer is no, because of the x squared. So it's not differentiable because there's a vertical tangent line at 0. Now on this one, I would say yes, it is. You can take the cube root of any number between -2 and -1 and square it and come out with a derivative. And that's in the original function, so you should be all right. Okay? See if there's another one. Oh, vertical tangent line at 0, 0, or a cusp. Well, f prime of x, 1/4, x to -3/4. The limit as x approaches 0 of 1/4 times the 4th root of x cubed. It doesn't take a rocket science to see it's going to be 1/0, which gives you a vertical tangent line. The question now is, for the cusp, is it ever going to equal negative infinity? I say that 4th root is going to stop it because the negative numbers aren't even in the domain to begin with. So the answer is yes for a vertical tangent, yes for part A, and no for part B. All right, that's probably far enough for right now. Give you time to work in class. Should have about at least 12 to 15 minutes to get started. Go through 1 through 27, 29 odd, something like that. We'll talk about these problems starting up tomorrow. Okay? So, I'm not sure what page it is. I don't get paid for that. But I do know it's on section 3.2. All right, so do 1 through 27 odd. Let's have a better time this time than we did last time I was gone. All right? Sounds good. Have a nice day, and hopefully I'll see you tomorrow.